great math, number 10. Okay, so now let's get started. Oh, by the way, today we're gonna work on some LCM. What is x? Finding what is x? Like finding what is x basically. 5 times x equals 30 minus x. What is x? It's probably like that simple equation. And we're also going to see if a number is prime, basically. So that's what we're going to do today. Let's start with the LCM. Now, you're wondering, what is LCM? LCM is least common multiple. What is the least common multiple, though? Well, least common multiple...
Do you have an example with clap and jump? Or I forgot, you told me something.
No, but I do have least common multiple of 3 and 4. Let's just use those. 3 and 4. So basically, it's all the numbers. So it's like 3 times 2. What is that? That's 6. That's 9. 3 times 4. That's 12. That's probably the max that we're going to go listing our entire number line. It's basically the two numbers multiplied together. Now, 4 times 2, that'd be 8. 4 times 3, that's being 12. There's no other numbers that are the same, so it's both of these. The least common multiple of 3 and 4 would be 12. That's the least common multiple. Unfortunately, the least common multiple was both the numbers that were multiplied together. So now, we're not going to use the same way because, well, you'll just see when you see the problem. The least common multiple of 900 and, okay, it's going to be worse, don't worry. It's even better. 630. Okay, there's 2 ways I'm going to show you, but I'm going to show you my favorite first. What is 900? Well, 900 would be 9 times 10 times 10, which that would be 3 squared times 2 times 5 times 2 times 5, which would equal to 3 squared times 2 squared times 5 squared, okay? Now for 630, what is that equal to? That's basically 63 times 10, which is equal to 7 times 3 squared times 2 times 5. So for the least common multiple, people think in this order, because you want to choose which, you have to choose some of these and some of these. People are going to think, oh, just pick the least amount of them, but that's not true. You want to pick the most because you also want the big number to also equal with it, not just a small number. So, since this and this, they're both third, they need to have at least 2 3s. So, you would need that. And you need 1 7 to be, at least you don't have to have any 7s to have 900. You don't have to. But in this case, you will, to make it also equal to 630. So, yeah. But what about the 2s and the 5s?
To be a multiple of 630, yeah. Okay.
But what about the 2s and 5s? Well, there's 2 squared and 5 squared, so you need at least 2 2s and at least 2 5s for this one. You only need 2 1s, 1 2 and 1 5. 2 2s should do it, and 2 5s should do it, because this one needs at the least 2 1. 1 2, I mean 1 2. Okay? And this one needs at least 1 5. This one has to absolutely have at least 1 2 and 1 5. That'd be it. Okay, now we just multiply them. So it's 7 times 5 squared times 3 squared times 2 squared, which that would equal to 7 times 25 times 9 times 4. There's the commutative property. We can move this around anywhere we want to make the actual result. So 4 times 25 times 7 times 9, which that would equal to 100 from these guys times 63, which would equal to 6,300. That's our answer. Some of you guys might not like this trick, but you might like my other trick. So this one, you keep repeatedly write LCM. until you actually get to the multiplication part, which was at the end of this one. So let's do it. Dude, what's common with this? There's 9, but we only can use prime numbers. But there's not saying that we can use a prime number with an exponent. So we'll use 3 squared, which is equal to 9, times the LCM of, since now you took away a least common multiple of these two, now basically you divide 9 out of this, so that would be 100, and divide 9 of that, that'd be 70. Now again, now you're seeing, oh, I'm going to use 10 now to make it 10 and 7, but 5 squared doesn't do it. That'd be 25. But you can do 2 times 5. So you can 3 squared times 2 times 5 times the LCM of 10 and 7. Now what's the least common multiple of 10 and 7? Well, 7 is not really common with any number really. So basically it would be 70. So it would be 3 squared times 2 times 5 times 70. Since now you already know the least common multiple, this is all changed to 70. Then which would equal to 9 times 10 times 70, which equal to 90 times 70, which equal to 630. I mean 6,330. 6,300 there. That would be your answer. And remember guys, you can use this for any other problem. Okay? So that's one quick way, because with big numbers, you don't want to just keep on listing all of them until it's the number times the other number that you're looking for the least common multiple. Okay? Now let's do search for x. 2 by x times 60 by the power of 3 is equal to 2 times 3 times 5 cubed. Now we're looking for what is x. So what I like to do is I like to see if I can break apart part of this problem to equal to this, okay? So basically I would break 60 apart, which would be 2x times, in parentheses, 2 times 30. And that's equal to 2 cubed times 3 cubed times 5 cubed. We're not going to touch this for a while though. Which would be 2x times, in parentheses, 2 times 2 times 3 times 5. Because it would be 2 times 2 times 15, but I have some time in my hand to do this. 2 squared times 3. Okay. Now you see this. So now we're going to do the same thing what we did to this, to this. 2x times 2 squared in parentheses, because 2 2's would equal to basically that. So by the power of 3 times 3 by the power of 3 times 5 by the power of 3. Well, since these two are the same, we don't have to worry about these. Okay, but we're not done with this. It would be 2x times 2 by 6, which would also equal to 2x plus 6, because when you multiply exponents, which would equal to 2 by the power of 3. Now, a positive integer with plus 6 would equal to by 3. That can't be positive then. That would have to be negative. So, you guessed it, it would x. So basically this would have to be -3, which would be which basically is a subtraction problem of 6 by 3, which would be 3, 2 by the power of 3. So x is equal to -3. And that's your answer. Okay? Remember guys, guys, you can use this for any other X or Y problem or whatever the letter is. Okay? Okay, now let's see. Now we're going to do our last one, which is see if the number is prime. Now, 61. Is it prime? Yeah. If I can squish that in. Is that prime? Well, let's see. Is it divisible? Well, 1, it's always with every number. By 2, well, it's not even, so 2 is gone. By 3, well, 6 plus 1, what is that, fellas? 7, so that wouldn't work. By 4, hey, we don't have to use 4. We don't have to use 4. Any number that is by 2, like all the multiples of 2, they don't have to be used, which is 4, 6, all the even numbers. So 4, 6, 8, 10, yeah. What about 5? Doesn't end with 0 or 5, so no. Then what about 7?
6. Oh, 6.
6, it's right there, so 7. Well, let's divide. But wait a minute, I have a shortcut way. 9 times 61, 9 times 7, that'd be 63. You don't have to use 9, 61 and 3 is already done. So, now what it would have to be, now all we have to do is check the primes. 11. Well, it can't buy by 2, 3, 4, all the way from 10. 1 to 10. And the maximum here would have to be 11 times 11, which would equal to 121. That's bigger. So any number we try all the way, it wouldn't work.
But we don't need to try any higher number.
You don't have to try any other number because you can do 12. 12 times 12 is 144. So on. You don't have to because it will not equal to